Okay, so welcome to the 5th lecture in software architecture. You might like to sit closer here, down there, so we can better see each other. But it's up to you. We're almost in the middle of the course. And before we start with today's topic, which is lean architecture and DCI, and some of it is surprising. You might find it surprising that it's not in the title, but it is related to use cases. You'll see how. I'd like just to kind of ask you whether is there anything you would like to get back to discuss, anything, any problems with the previous topics or whatever. If not, then this lecture will be shorter because I'm participating in the conference on pattern languages of programs, as I actually informed you. And I got a session at 3 p.m. So I'll need to rush there. So after the lecture, I'll try to make some time to. If anyone would like to discuss anything individually, there might be not too much time for that after the lecture. So, is there anything like that you need me to leave an ample time for this? Viac času, potom ak niekto má otázku na konci prednášky, ja nebudem mať veľa času. Okay. Nevertheless, the lecture will be, I'll try to make it interactive, but it's up to you. So we are here expressing software architecture in UML. This is lean architecture and DCI. You'll see what does the mysterious acronym mean. And the next lecture, we return to patterns, but to patterns of people. And then more technical topics like software product lines and distributed software architecture, again with patterns, maintaining software architecture, and our guest lecture, container-oriented software architecture and its implications. And finally, aspect-oriented modularization. So I did not change the schedule this time. I hope this will remain like this. Okay, I think we can start then with today's topic. Today and the day before and so on, and actually for quite some time, we speak very much about agile software development. You heard this, even like you operate with this notion and you develop according to this approach or way of developing software, your team projects. So the question then is, when you're using it, what does it mean to be agile? When we speak about agile software development, it's something very positive, good. I think kind of we quite know each other by now, but if you need to you may talk to each other, consult your opinion, and then help me figure out what does it mean to be agile. I'm not sure anymore. how do you feel about this? What do you think it is? What do you find it is? Our Erasmus students are not participating in the team projects, as far as I know. So they might have participated in some other projects related to Agile, or that tend to be developed by Agile principles or adhere to Agile principles. What does it mean to be Agile? Give me some hint. You only started with your team projects. Well, you will find out that you are going to be kind of motivated or pushed to develop them fairly quickly. It is a year project, but the time is quite limited because it's not a whole year. It's actually 2 times 12 weeks, maybe something in between. So, and the tangible result is required at the end. You've been told that you have to develop a working software system, something that corresponds to what you've been asked to develop, but you have not been given a complete specification that you need to follow step by step, and then you know what to do. So you're discovering yourself what to do. You're talking to your supervisor and maybe some other people that represent what the product is to be. And you need to create something operational very, very quickly and to present the results, and then correct the things that you developed according to the feedback that you get. So Agile as a notion means something as being swift in moving, quick. Maybe you've heard that responding to change is the key, and that you need to start to develop from the beginning your software, despite you don't know exactly what it is meant to be. And then, then the response to change is very, very important. So you will be mostly responding to change. Is responding to change the only thing that matters? To start talking to your customer or client or some representative, or your product owner embodies your customer. Your product owner is the one who can, a live specification as a human being, that you can ask always whatever is unclear. Your product owner might not know the answer, but it doesn't matter, because he must find the answer. He is responsible for this. He might have a whole team working for him to cover this. But in the end, there's one person, according to Scrum. So this is why this is so in Scrum. One person who is really responsible for this and will be held responsible if something goes wrong with the project direction. Okay, you might be then held responsible as the development team because you did not develop things that you should have developed, but this will be quickly figured out. So the thing is, quickly go and develop no, doesn't really matter. We don't know what it is, but let's develop something. And then it doesn't matter because we will be changing it. So then we will be changing it to one side and to the other side, and then I don't know what. What that you think would do with your architecture? What if you would be building or setting your building like this or any other building with only a change on your mind? So you'll be setting something and then deciding for something else and constantly rebuilding it. What about foundations? They will be very, very weak. So you know, but you need to be able. So it's not quite like building software is not very. It is being compared to building architecture, but or civil engineering, but it is not that stiff. Like it's more like it's not that difficult to change code as to move heavy things, heavy material to some other place and get some other material and put everything together and so on. The construction business is very, very difficult with respect to this. So we can very quickly change very much. But there are difficulties when you set up the foundations and then you need to change these foundations because this will affect many other things. So it seems that we can also, in building software, decouple two perspectives, two basic perspectives. So what is stable and what is our foundation that enables us, that should enable us to be agile. So something to kind of have as a basis, but then to be able to adapt to ever-changing requirements. What kind of crazy requirements can come there and so on? You don't know, especially if you develop for several customers, several clients. Some might be contradicting, some might be very complex in their relationships to other requirements and so on. And for this, you need to have something that you can walk upon and do these things. So this would be your agile architecture. That will serve this purpose. So we can think of this also from a different side. We need to understand what are the needs, or what kind of basis this should be. Like, sure, we don't want to build very much. We need as much as needed. So if we take this client or customer perspective further, and how do we deliver to customers, to clients? What do we deliver? There are strategies, selling strategies, marketing strategies that like enforce the viewpoint that you should build very much of pre-planned things and then push them to the market and then sell them, maybe aggressively marketing them and so on, and eventually will sell them. But no one will be satisfied with this, and you will be also unhappy, and you might end up selling nothing And why do you do this? Just to make some profit. But the idea with agile movement is to build things and respond to the requirements that you have at hand, that you want to help your client. You want the money from the client, but you want also to be useful for your client, to provide something useful to them. And a more appropriate strategy for this is not to push things, but to pull things, to let your client pull what is needed for them. So you don't build too many things and then force your client to accept this, but you build only as much as needed, and then let them pull other features from you. This means also, consequently, avoiding producing waste, because in agile world, your customer can tell you that they don't want some feature, so they want this reverted, and they want this some other way. So after each iteration, there is a possibility to reconsider what is built and to decide how to proceed. So this pull, don't push strategy and avoiding producing waste is related very much to maintaining some contact with real end users. And there is a topic for master's thesis by one of my PhD students, Daud, regarding this, because there are some difficulties in identifying who is the real end user sometimes, because sometimes people are sent to you that pretend that they will be end users, but they are not actually. They're just doing their job. And they cannot admit to you that they are not really end users. So there are even patterns for this. So end users, and to avoid producing waste means to make decisions at the responsible moment. Some people tend to make decisions as quick as possible, but when you don't have enough information, you might be making wrong decisions. Some people then say, make decisions at the latest possible moment, but then it might be too late. Maybe at that moment it wouldn't be too late, but how do you tell? Is this really the last possible moment that I can make the decision? I'm not sure. Let's wait until tomorrow. And then it's past the deadline because some other things happened and you no longer have the possibility to take that decision and to implement it. So when you're sure, when you think, you might be never sure, but when you think that things the situation is right for making a decision, make the decision, decide what classes, what modules, whatever there will be. That's what is it about. And this is not called agile. This is called lean. Lean means something like thin or adhering to surface, leaning towards something, or being close to something, not being kind of huge, like not having fat architecture that you need to fight with, but something really, really, really kind of lean budget. Lean budget is not a kind of huge, comfortable budget that you can make all kind of expenses for unnecessary things. It is sufficient for you what you need to do. It's lean. This is lean. This is the lean philosophy comes from Toyota and previously Toyota. So it's very much from Japan, but it is actually, I think, very much in human nature. So some people tend to interpret this or like emphasize the Japanese roots of the lean philosophy. Okay, there are Japanese roots to it, but certainly we all bear this inside of us as human beings, and you might be surprised, but I think of it a bit sometime. I think that the great source for this or inspiration for this is natural laziness. I don't want to do any things that I don't have to do. Sometimes many times when people rush to do all kinds of things, they spoil half of the things, at least. And they produce waste. Then they have to redo this or engage other people to correct the things that they messed up. And Japanese are not thought as being lazy people, quite on the contrary. Yeah, so it's strange a bit. Anyway, lean is the foundation. So all this requires to have this strategy. It requires to have some kind of order, some kind of architecture. So for developing software, we need some architecture, but only as much as necessary. Then this architecture is lean architecture, and then we can be agile. However, we'll talk about this at the next lecture because it's devoted to people. And you know about Conway's law. I won't remind you today of this law, but let's leave it for if you forgot it, let's leave it for the next time. But I think as talking about this, I've been constantly mentioning people. So it's not about just, think of the architecture, it is like organized like this model, when it is connected to this one, and this component to this one, and so on, and this is our architecture, and if we have this like that, according to this scheme, then we are fine. No, we are not. It is about people and how people are organized and how people work together. Mostly, it is about people. Software is mostly about people. So this is the Lean secret from Koplin and Bjornvik from the book on Lean architecture, which says everybody all together from early on. It doesn't mean that you need to take hundreds of people and push them into one room, although it might be better if a bit more people would be in this room. It means that you need to that everyone needs to pay attention to be kind of included in the process, to follow what's happening and to be able to react if it's possible, or if it's necessary. So especially in those critical moments. And the most critical moment is when we start with the project, to understand what do we have and what is it about and who is actually needed at that moment, and then how the things will develop. So everybody all together from early on. We'll talk about this as well more later, but there is a kind of something like mantra. If you forget about Scrum, about everything, about all the things that you've been taught with respect to organizing software development and management in software development and all such things, when you are shocked with the complexity of the problem and the responsibility that you are taking as a young software architect or some kind of software manager or whatever, or a developer, then Alistair Cockburn says all you have to remember is this mantra that you need to collaborate with other people. Don't forget about this. So without collaboration, you will not develop a working software system. You need to deliver something that's maybe the most essential thing because it is expected from it. This is the expected result. But to deliver, you need to collaborate. In order to deliver something, you cannot do all the things right from the beginning. So you need to improve the things. And to improve, you need to collaborate with other people. And in order to improve things, you need to reflect on them, to think of them, to consider them, reconsider them. And for this, you need to talk to other people, so again, collaborate. And this is called, this heart inside of this scheme signifies that these notions are around the heart of Agile. So this is the center of Agile is there, but we don't know. We don't know what it is. We cannot describe it. We can go around it, and the closest notions to it, according to Alistair Cockburn, and I find them this idea very appealing, are these. So if you forget about everything, you should remember about this. And you'll be lean, and by this you will be enabling Agile. Let's move further. Let's consider this example. So this is kind of the philosophical foundation for what I'm going to talk further. Let's imagine you're developing a software modeling tool. It might be a graph modeling tool, or it might be a model-aware tool. Do you know what the difference is between these two? When you're drawing graphs of your software system or intended software system, when you do it on paper, you're drawing some graphs. You can do a better job if you use some tool like Visio, where you can draw your graphs and maintain them. Nodes connected with other nodes, you have edges. If you move one node, then your edge will not break, it will be pulled with your element, so the connections will remain, and you can restructure it, add other elements, delete something. So it's more flexible than doing this on paper. Yet, if you want to draw another diagram with the sum of the elements repeated in the diagram, you can do that. But when you change the name of one of the elements in one of these diagrams, it will not change in the other one. Because for that graph drawing tool, these are just nodes. It is not aware of the semantics behind these nodes. And a model-aware tool like Enterprise Architect or Rational Software Architect or any other UML modeling tool, these tools are aware of what the elements represent and actually your diagrams are just views of your model. So this is quite a different thing. So imagine you need to develop a software modeling tool, and then you say, okay, I will ask my client about, or my intended customer, or some people that I think might be using my tool, what do they need? They will be telling about the colors they need, the shapes they need to be incorporated there, the kind of edges, and zooming in and out, and other things. But if you miss this point, then it won't be a good tool. So the thing is that you might have known beforehand, before you started, what the system is, if you know your domain. And this is different from what the system does. All the fancy features, I don't know, zooming out in and out, and combining the diagram views, and all kinds of things. So inside your system is a structure of connected elements. It is a kind of a database of these elements. And you need to present these elements somehow. You might present them more appealing way, less appealing way, more flexible way, less flexible way. This is also something to consider. But if you do a lousy job putting on the foundations of this system, you cannot make it in this perspective of what the system does. So you must understand what the system is. And this is something that you barely understand by interviewing your customers. So unless you are doing or working in a domain that there are no other systems in that domain, no experience, it's a kind of a completely new domain, then you have no other option than to explore it by interviewing potential customers. Domain knowledge is what you're actually considering when you are working in this perspective, what the system is, the domain knowledge. If you are a domain expert, then you have the domain knowledge. What to do if you are not a domain expert? Well, become one, or find one, buy one. It's a necessity. On the other side, we have end-user mental model. So the idea of users, what do I need, what features do I need in the system? Within this, what the system is perspective, we structure our system into some kind of objects, not necessarily object-oriented objects, but some kind of entities. It's more about data, slightly, than about functions or roles that these objects take, play these roles, save the data. So whatever is achieved is saved as some kind of objects, some kind of entities, and they are released from these roles they played. It's your modeling element that you need to zoom into, or to display some kind of a detailed view of this element with all the attributes, and then you need to switch to the other view, or you need to add an element, or to combine two elements. So they will be taking this role, they are combined, and then they are released. And they are saved, and they are like residing there in their normal object state. And these functions of software system happen actually as interactions of roles. rather than directly. We do not think of interactions between we actually are taught that in object-oriented world we model everything as objects, and then we think of the interactions as interactions between objects. But actually, this happens above the objects. The objects are taking some roles, they play in these interactions, and then they are freed of these roles and continue residing in their persistent world. And this interaction of roles is actually related to use cases. So what happens between the roles? We don't need to think about objects when we create use cases. So remember use cases. You don't think of your object-oriented design directly there. You don't have to bother with it. And it's a very much understandable view to your customer, to your end user. So this is the end user mental model represented. This is a very dynamic thing and ever-changing thing, and many changes happen here, often. You add new use cases, you modify use cases. Here, you don't want very much things to be changed. You want this side to be kept stable as much as it can be. Of course, there are some changes over there as well, but you don't want the changes in your foundations. And how do you come to this domain knowledge if you don't have one? Or how do you, if you have some domain knowledge, then you have to kind of, again, to reconsider it, to understand things. You do some kind of analysis, and this analysis is called domain analysis. You analyze the relationships between your objects. And some things there might be compulsory, some might be or stable, more stable even, or required. Some might be variable, changing, variable, like variations are possible for different settings, different customers. We'll be talking about this in the lecture devoted to software product lines. But it is important to consider this even at this moment, so that there is commonality. So this is the other word for what I was the word that I was looking for. So for the required part, mandatory part, compulsory part, commonality. What is common between the systems in the domain, among the systems in the domain that you develop, and what is variable. So what will remain stable versus what is likely to change. So when we think of what domain knowledge actually is, we might consider this definition: a timeless compression of the mental models of end users and other stakeholders, mental models whose patterns are tacitly driven by commonality and variation. This is a definition by Koplin and Bjorvik from the Lean Architecture book. And this is something that speaks in favor of finding or talking about analysis patterns. So there are even analysis patterns established for different domains. So repeating structures, domain structures that you have that you know there are, that enable you to quickly establish what you need in your domain. However, as I said, if there is no sufficiently established domain knowledge yet, you must rely on the end user cognitive model of the domain. And you should consider all end users. So you should be imagining if you want to build a really stable foundation for your system, or a family of systems, which is most often the case. Probably if you enter some business with that business with software modeling tools, you'll be developing at least you'll be improving your software system and developing new versions, but you might develop custom modeling tools for one domain, the other domain, or some modeling language, not just targeting UML, because many of the things there are very similar between these modeling languages. And when you understand how to do this business, you will be wanting to make use of this. So actually, your architecture is something like a thin string or several strings, not too fat, not too thick. Okay, and there are like pearls, use cases put on this string. So this is what holds these use cases, and it is necessary to build use cases. But your customer wants to see the pearls, not the string. But for the pearls to be seen, you need that string. Yeah, so you can add further use cases. You can move them from the string without actually having to cut the string or strengthen the string. Sometimes you need to put some other string there as well for some use cases. But then you need to go through all use cases that you have there, because this will probably affect them. So this is the perspective of what the system does versus what the system is, again. This looks like a game or very much metaphoric thing, but we are getting to some more technical stuff. Before that, just to remind you that the system architecture has to reflect the end user cognitive model, being able to accommodate emerging use cases. So this is something to think of, and this is how one of the possibilities to treat this, or to treat this technically. You might think of the system that I mentioned before, of the system, the eShop system, and you might think of your use cases. I did not represent this as a use case diagram, but your use case in the implementation. So this is like not a use case diagram and how use cases are structured, but how use cases are to be implemented. You might think it might be good to and we displayed these I just displayed these use cases as pearls. You might be interested in preserving these pearls in your program, so not to let them spread around your code, all over the code. So your use cases are typically spread all over your code. So in order to find your use case or what code is related to your use case, you need to go through all your code and to follow the relationships. So it would be nice if you could say this class represents my use case. And to the great extent, you can do this, because much of the functionality that is in that use case you can implement as simple methods. And this use case operates upon some objects. Like this is the place and order use case. It operates on the order being placed, operates on the selected product, and then it operates on placed orders. These things are all included within this use case. these roles, you can represent them as objects in your program. But these objects are not the same objects that will be stored in your database. These will be like operating, these are more like interfaces to your real objects, which are order, product, order list. And here they are represented as an example of a running system like objects. So this is some kind of my order, some kind of computer that I'm ordering, and this is a placed order list that I'm maintaining. So effectively, this is establishing a database model, something like this. Not necessarily relational database model. It can be an object-oriented model or schema. So how are your essential objects related to each other, essential entities, how they are related to each other, and how they are stored? Their instances, of course. This is the domain knowledge. This is your user perspective. So this is to go down to the bone, we can say just this is data. We should not be ashamed of this. This is data, simple data. The data is what is produced and then stored, and this is what matters. But how do we operate with data? So we need complex mechanisms in order to come close to the customer, to their mental model, to enable them manipulate this model. You don't expect your customer to enter the database and manipulate directly these objects. Not even you want to do this on a daily basis. You can do this, like make some corrections to your database, but to maintain the business of modeling some software or maintaining an e-shop by directly entering data into your database, it's crazy. And this thing up there is the context in which the data is into which this data is placed. It might be placed into some other context. This is the context of placing an order, but there might be other use cases like for delivering the orders. And the same data will be there engaged. So this is your context are use cases, and the interaction is guided through these roles. And this implementation, so this is data context interaction, DCI, data context interaction. Do I have this written there? No. Data context interaction. Approach, which is actually the thing that implements the philosophy that I presented at the beginning of the lecture or through the most of this lecture. The philosophy is more important than the implementation, of course, but it is good to know that there have been some efforts, and this is implemented in several programming languages and attempted to maintain things like this. But some architectures come closer to this, some not that much. Even if you do not completely go according to data context interaction, you should come close or trying to come close to this. So this is the idea. And you will have then less difficulties of maintaining your system because you will be decoupling what is stable from what is ever-changing. Of course, if you go through this, you will be implementing many kind of other subordinate to say so use cases or include only use cases according to this Coburn's scheme of where the real use cases sit. They are floating, but down in the deep water there are those use cases that are used by other use cases. We can think of them as use cases if we are thorough with use cases, but most often we specify only these use cases here and very few of these down there. But for this approach, you will probably need to go deeper to sub-functions. So data, context, and interaction. It decouples the stable part of the architecture, domain objects, from its variable part, use cases, with their flexible binding roles. This is the summary. So this is roughly it, what I wanted to present to you. This will be the approach. DCI is one of the approaches aiming at preserving use cases in code, with other ones being aspect-oriented software development with use cases by Jakobson and use case-driven modularization we've been exploring here is also one of the approaches. And you might also consider take into consideration that some programming languages are more appropriate for this, some less. Some more dynamic languages that enable you to implement dynamically role binding are more appropriate, but DCI has been implemented even in C++. This is another attempt that we've been exploring here, but I'm not going to talk about this now. So I will just conclude like this. Lean enables agile. The system architecture has to reflect the end-user cognitive model being able to accommodate emerging use cases. And use cases can be seen as interactions of roles bound to domain objects. And there are real implementations of this. And some implementations that hidden from our eyes, like in companies know-how, are actually maybe coming close to these ideas, but the people simply do not promote this in the open space. So that's it for today. Any questions? It doesn't seem so. Okay, so thank you very much for attending this lecture. We'll meet next time, and that will be a kind of full lecture then. As I said, I must rush now to the meeting, the conference, so see you next time. Jakub? Možeš?